some parameters which we saw with respect to the noise performance is noise factor, noise figure, and noise temperature, and some other numerical parameters which will bring down the performance of systems, or we are going to continue with our discussion. So that is going to be harmonic distortion. So this is more or less, it is going to distort your signal in such a way that the receiver will not be able to identify what is being sent. So, distortion is something which the change of shape happens in a signal. And harmonic means it is integer multiples. So if generally for any mathematical thing, we'll assume we are going to apply a sinusoidal signal. So here also assume that we are going to apply a sinusoidal signal to an amplifier, and an amplifier is going to have this non-linear characteristics. So usually all amplifiers are considered to be linear. Linearity means whatever input frequency you provide, the same output frequency should come out with an increased amplitude. That is linearity. But all ideal amplifiers are linear, but all practical amplifiers are non-linear. So non-linear means your linear means y is proportional to x. That is a simple way of saying linearity. But when you say non-linear, y is proportional to x plus y is also proportional to x square. So this x square is a parabolic waveform, so it becomes non-linear. So the same analysis we are going to see what is the case if my amplifier is going to be non-linear in nature. So if I'm going to apply a sine wave, what will I get my sine wave alone, or will I get extra components? We are going to see that. And see here, y of t equal to alpha 1 x of t plus alpha 2 x square of t plus alpha 3 x cube of t. So this amplifier is going to have linearity up to the level of 3. The first component is our original frequency, second component is square, third component is cube. So substitute x of t, you get alpha 1 a cos omega t plus alpha 2 a square cos square plus alpha 3 a cube cos cube. So you have formulas to convert cos square into cos, cos cube into cos. So use the formulas, and we are converting all the cos square and cos cube terms in terms of cos. Now you group the common terms. There is one term which does not have frequency, that is called as a DC term. It is alpha 2 a square by 2. This is your DC term. And cos omega t term is present in two places. So you have alpha 1 a plus 3 alpha 3 a cube by 4 into cos omega t. And you have one cos 2 omega t term and one cos 3 omega t term. See, I am giving only one frequency as input, but I am getting DC, my original frequency, harmonic of my original frequency, the next higher harmonic of my original frequency. So I am getting additionally one DC plus two other frequencies, and these two components other than my original frequency are called as harmonic distortion. Harmonic means it is integer multiples. If f is my original frequency, harmonic distortion is given by n into f. And n value can take from 2. N can be 2, n can be 3, n can be 4. Here you see, I have n is equal to 2 term. Here I have n is equal to 2 term, n is equal to 3 term. If you put n is equal to 1, you get back your original signal. And this DC, you can use a capacitor to remove the DC. That's not an issue. All the problems are caused by cos 2 omega t term and cos 3 omega t term. Just because they are present in the equation, what problems they are going to cause? They are going to share the signal power, which is meant only for cos omega t. So it is just like a rich father is having only one son, the entire property will go to that son. But if the father is having 4 or 5 sons, it has to be divided among all the 5 sons. So the net property going to each son is less, right? The same example. So if only my signal is there, the entire power will be available across signal. But if I have signal plus so many harmonic distortion, power is available across all these terms which are considered to be unimportant or unwanted for my receiver. So these terms are coming under the name called as harmonic distortion. So harmonic distortion can be analyzed only in a mathematical way. So that is why we have taken a sinusoidal input given to a non-linear